All right, hello everyone. So today we're going to talk about solving systems of equations by substitution. So we've already solved our systems by graphing before. Now we're going to try another way, and that's going to be by substitution. So I'm just going to be really clear about this. We're still doing the same thing as we did with elimination. Not elimination. Graphing. When we graphed, we took both of our equations and we just put them on a graph and saw where they crossed. This is still the same idea. You still want to find that point where they cross, but this time we're not going to have like a visual representation of it. We're not going to have a graph to see where it is. We're going to find that out by calculations. So, our question here says, how do you solve a system more accurately? It's going to be this way, because sometimes we'll get a system where their solutions will be decimals or something like that, and we can't really tell that from a graph. So this is going to be a more accurate way to solve these. Okay, so let's take a look at what I have over here. I have a system, but I underlined this part and I drew an arrow to the y. Okay, so word substitution. Substitute, like a substitute teacher. When your teacher is gone, your substitute teacher will fill in for them. They're literally trading out your teacher for a different one. So, same thing, only we're trading stuff around. And that's kind of the idea here, is that you're substituting something out for something else. So let's take a look at the inside of these notes. I'm going to go to the top here where it says to solve by substitution. So these are going to be the rules or steps that we're going to follow to solve. So we got step number 1 is to find y equals. You're going to end up with something like y equals something or other. That's what you want. You need to find what your y equals or what your x is equal to. Both of these are going to be totally valid ways to solve. It's just usually our y will come first. Okay, step number 2 is going to be where we substitute our y equals into the other equation. So when I say substitute, remember, I mean replace or trade or plug in or something along those lines. You're taking your y out and putting in something else for it. All right, step number 3, you're going to solve for x. Once you find what your x is equal to, you're going to substitute it into your other equation to find y. So basically, your job here is to solve for x first and then solve for y. You're finding both of these numbers. So you basically have 2 problems in one. So let's take a look at an example and see what that actually looks like. Okay, I'll keep both of these up here for us. So let's follow the steps. We got our little system right here, and we're going to go with step number 1, find y equals. Okay, well, I see right at the top here we have y equals, and it's going to be 2x plus 2. Cool. Step number 1 is done. All right, step number 2, substitute y equals into the other equation. So I'm going to take this entire bit here, this 2x plus 2, and I'm going to put it in for my y. So I'm just going to trade it out. So I'm going to put in that piece there. How I'm going to do that is I'm going to copy this exact line, but instead of y, I'm going to put in this thing. So I already have that set up for us here. So we have 6x plus not y. Instead of y, I'm going to put in that 2x plus 2. And then we have our equals 10 over here. So, like I said, this is the exact same thing, only instead of y, I put in this guy. All right, so let's continue with this. This is basically just going to be solving from here. So we got 6x plus 2x plus 2. Okay, so I'm going to look right here. I don't see any numbers here, so that means there's going to be an invisible 1. So I don't have to distribute anything here, which is really nice. So I'm just going to drop those parentheses. And like I said, the only reason why I can do this is because I don't have any numbers on the outside besides a 1. Okay. Now, like I said, it's just going to be solving from here. So let's look at this. We got 6x plus 2x plus 2. Okay. I already see that we have 2 x's here. So what I'm going to do is is combine like terms. These both have x's on them, so I know that I could add them together. We got 6x plus 2x. That's going to give me 8x. I still have that positive 2, and I still have a 10 over here. All right, so still solving. I want to get x by itself, so I see that I have a 2 here. That's the next thing I want to take away. I got plus 2, so I'm going to subtract it from both sides. That's gone. So now we have 8x equals 10 minus 2. That's going to be 8. And then last step, I need to get rid of this 8, so I'm going to divide by 8. So that's gone. And we'll get x equals 8 divided by 8, which is 1. Cool. That gets us to step 3. All of these steps are done. Now we just have the last 2. So we're going to substitute x into the other equation. So what that means is I'm going to take this x that I just found, it's 1, and I'm going to put it in here, the one that we substituted in. So I'm going to give myself a little bit of space here. I'm going to cordon this off. I got y equals 2x plus 2. Now I'm going to do the same thing. Instead of an x, I'm going to put in what I know x to be equal to, which is 1. So I'm going to say y equals 2, parentheses 1, plus 2. All I did was replace that x with a 1, because I know that's what it's equal to. All right, now I'm just going to solve. So we got y equals 2 times 1, that's going to be 2. And then 2 plus 2 is going to be 4. So y equals 4. And those are both of my answers. You have to have both of those for that to work. Okay, that is that. So this is a lot like when we did our functions in our last unit, and it's also like our topic 1, which was solving. So we're kind of bringing it all together, building on top of what we already know. So this is kind of a review, kind of newish. It's kind of both. Okay, so let's take a look at the first question in the rest of these notes. We only had 4 for these, so I'm not going to do all of them. I just want to look at number 1, because it's a little bit different. Okay, directions say, solve the following systems by using substitution. All right, so let's see what we got. All right, following the same steps that we did last time, we want to find y equals first. Okay, well, y equals a negative 2. Cool. All right, next step was to substitute. So I'm going to take my negative 2 and I'm going to plug it in for y. So I'm going to rewrite my bottom equation. That was 4x minus 3y, but not y. I don't want y. I want what we said y is equal to. I want this to go in here. So we got negative 2 equals 18. Okay, cool. Now we're just going to start solving, but I see that we have this here. So I'm going to solve that first. We got 4x, didn't get touched yet, and a negative 3 times a negative 2. That's going to be a positive 6 equals 18. All right. Next thing I want to get rid of is that 6. It's positive, so I'm going to subtract it. I'm going to have 4x equals 18 minus 6. That'll be 12. And then I'm going to divide by this 4, so that goes away. And we get x equals 3. That's our first answer. Okay, second answer, we still need to find what our y is equal to. Luckily for us, we already know that. At the top here, where we usually plug it in, we already know that y is equal to negative 2, because that's just a number. That's already done for us. Now, not everyone is going to look like this. I just wanted to throw this in here just for reference. But yeah, that one's basically already done. So in class, we did 2, 3, and 4 on our own. But let me know if you have any questions. But that's going to be about it for this one. I'll see you later. Bye.